Can you solve this math challenge? Here's the question. Solve for the value of x and y. Given this equation, x plus xy plus y equals 3 and x squared y plus xy squared equals negative 70. Now you can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright, so, given these equations, x plus xy plus y equals 3 and x squared y plus xy squared equals 70, our goal is to solve for the real value of x and y. Take note that x and y here are real numbers. So, to answer this question, first, let's use the second equation. Because, take note, x squared y plus xy squared, we can factor out xy in these two terms. If we do that, we get xy multiplied by x plus y. So, let's replace this. And now, let's use the first equation. But before that, let's rearrange xy and x. Why we do that? Because we will use some dummy variables. So let's call this xy as a, and x plus y, let's call this as b. So we can replace all xy with variable a, and x plus y with the variable b. But again, take note, keep in mind that a equals xy and b equals x plus y. Now, using these two equations, we can now easily solve for the value of a and b. So, first, let's solve for the value of b. Let's subtract a on both sides, so b equals 3 minus a. From here, we can now replace this b with its value 3 minus a, like this. But again, keep in mind that b equals 3 minus a. Alright, now let's solve for the value of a. First, let's distribute this a to 3 minus a. This will result to 3a minus a squared equals negative 70. Next, let's equate this to 0 and rearrange some terms a little bit. So we have 0 equals a squared minus 3a minus 70. Now, using this equation, take note that we can factor this as a minus 10 multiplied by a plus 70, because negative 10 plus 7, this will give us negative 3, and negative 10 times 7, this will result to negative 70. So we can factor this as a minus 10 multiplied by a plus 7. Now let's use this factored form. Next, we can now solve for the value of a, because since it is equal to 0, we can say that at least one of them must be equal to 0. So we have a minus 10 equals 0, or a plus 7 equals 0. Now let's add 10 on both sides to solve for the value of a, and sure enough, we get that the value of a equals 10. Now in the second case, if we subtract 7 on both sides, we get that the value of a must be equal to negative 7. Now using the fact that b equals 3 minus a, if a is 10, so 3 minus 10, b must be equal to negative 7. Now if a equals negative 7, so we have 3 minus negative 7, b here must be equal to 10. So, using these values of a and b, we can now solve for the values of x and y. Now, let's have the first case, wherein a equals 10 and b equals negative 7. So, we know a equals 10 and b equals negative 7. Alright. And now, we can now solve for the values of x and y. Now, using the second equation, let's solve for the value of y in terms of x. So, y can be written as negative 7 minus x. So, let's replace this variable y with its value negative 7 minus x. But again, take note that y equals negative 7 minus x. Now, let's solve for the value of x first. So, let's distribute this x to negative 7 minus x. This will result to negative 7x minus x squared. So, let's rearrange some terms a little bit. Let's make the coefficient of x squared a positive integer. So we have here x squared plus 7x plus 10 equals to 0. Now, 7 is 5 plus 2, while 10 is 5 times 2. So we can factor this quadratic equation as x plus 2 multiplied by x plus 5. Now, using the zero property, we can say that x plus 2 equals to 0 or x plus 5 equals 0. So x on the first case is negative 2. On the second case, this will give us negative 5. Take note that y equals negative 7 minus x. If x is negative 2, this x becomes negative 2. This y becomes negative 7 minus negative 2, or simply equivalent to negative 5. And then, if this x is equal to negative 5, this is negative 5, so y equals negative 7 minus negative 5, or equivalent to negative 2. So, we found two values for x and y, two pairs. If x equals negative 2, y equals negative 5, or if x equals negative 5, y equals negative 2. Alright, but we're not yet done, because on the other side, we have if a equals negative 7 and b equals 10. So again, using these two equations, we can also solve for the values of x and y. Now, using the second equation, let's solve for the value of y again. So, y equals 10 minus x. So, replace again this variable y with 10 minus x. Again, keep in mind that y equals 10 minus x. So, let's solve for the value of x. Distribute this x to 10 minus x. This will result to 10x minus x squared. Again, rearrange some terms a little bit. Let's make the coefficient of this x squared a positive integer. So we have x squared minus 10x minus 7 equals 0. Now, this quadratic equation is not factorable. So, to solve for the value of x, we will use the quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. Now, the value of a is the coefficient of x squared, which is equal to 1. B is the coefficient of x, which is negative 10. And c equals the constant term, which is negative 7. Now, let's replace all a with 1. And then all b with negative 10. And then c with negative 7. Now, let's simplify. Negative 10 squared will give us 100. Negative 4 times negative 7, this will give us positive 28. So, the number inside the radical sign must be equal to 128. Next, negative of negative 10, this is just positive 10. And square root of 128, we can simplify this. Because 128 is 64 times 2, and square root of 64 must be equal to 8. Now, 10 plus or minus 8 times square root of 2 divided by 2, this will give us 5 plus or minus 4 times square root of 2. So, we have two possible values for x, namely 5 plus 4 times square root of 2 or 5 minus 4 times square root of 2. Now, we know that y equals 10 minus x. So, if x is 5 plus 4 times square root of 2, 10 minus this guy right here, this will give us y equals 5 minus 4 times square root of 2. Now, what if x equals 5 minus 4 times square root of 2? If we replace this value to x, we get that the value of y must be equal to 5 plus 4 times square root of 2. And we found another two sets of the values of x and y. So, in this question, we have 4 pairs of x and y, namely negative 2, negative 5, negative 5, negative 2, 5 plus 4 square root of 2, and 5 minus 4 square root of 2. Or, if x equals 5 minus 4 times square root of 2, y equals 5 plus 4 times square root of 2. And as always, we are done.